I've got the bike off the table and on some jack stands so I can get access from up underneath, so I can start removing some of these parts that we're going to be replacing. I think I'm going to start with these little control levers right here. This is probably our third or fourth version of these. The original version literally fell apart as soon as the bike was finished, and we just started super gluing it back together and back together and back together, and we ended up taking this for the first weekend out. The following weekend we ended up going to another con, and I remember they just literally fell off in the back of the truck on the way to that con, and luckily they all fell between the bed and the tailgate. As the tailgate was open, they were all sitting down in that trough, and we didn't lose a single one, so we were able to glue everything back together and have it for the con. And then we built another set. Those got broke off. Then we built another set. Those got broke off. Then we built this set and changed how we instructed people to get on and off the bike, and came up with a whole new kind of protocol that we could teach everyone that volunteered to help. We stopped breaking these off after that. People tended to swing their leg over and then crash everything with their feet. Once that was done, these have been on for several years, and they're quick and dirty, and they were never meant to be perfect or permanent, but in a jam, and they just never got broke again, so we never replaced them again. But here we are, we're going to replace them now. Here's a quick shot of the control panel and the levers I'm talking about. I've remembered how we did these, and the whole time I thought this construction, the way it looked, was wrong, and I had all these plans of really crazy ways of redoing this to make it look really cool. And I was able to locate some photographs of the originals and realized that everything I was thinking about making is way more than what they actually were. And I'm going to go ahead and take these off now. As soon as we're done with that, we're going to go look at some photos of the original SpeederBike, a screen-used SpeederBike, and talk about how we're going to build these and what I kind of discovered in re-examining some of these photos. So let me get started and taking these off real quick. All right, coming up from below. Alright, so we'll gather these up. We'll go take a look at the picture that I actually have found and discuss how we're going to go ahead and remake these out of aluminum. Okay, here's one of our reference photos, and you can see here's the little controls we're messing with right now. Now, when we originally built ours, here's the rod, or the control. We intended for them to toggle, do this. They don't. The originals weren't designed to do that. So I'm actually going to rebuild the next set exactly the way they should be built, and not the way we have been building them. I had a whole way of mocking this up on the mill and using a rotary table and cutting this to where these two pieces fit super tight and nice, and we're going to run a pin through, anchor these two pieces on the outside, and have it do. Totally unnecessary. It's not what we need to do. So let me find, I got a better photo, and this other photo is actually of a different bike. Still a screen used bike, but this is a much better, more close-up photo. Now, some of them do sit at an angle, but they're not toggled over at an angle. And we'd actually done this already because we noticed this angle, so we cut some of these at an angle so they fit like this. I believe these two pieces here, and there's a hole drilled through here, and the whole thing is just screwed or pinned together, and there's no movement. They're static. They won't move or do anything. Some have angles cut on the bottom of them, so they lean one way or lean the other, and that's what we're going to do. This piece here is a greebly that I'm actually very familiar with. It's a common greebly on a lot of different blasters, and it's on spaceships. It's everywhere. This Greebly is all over the place. I think you'd be hard pressed not to find something that this is not on. So anyway, I got this, and I noticed right here underneath all of them, looks like they have a washer. So we're gonna put a washer underneath, and I've got, which I believe is a little bit larger, but it fits the size of the cutouts in our dash a little bit better. I got some 1/2-inch aluminum rod that we're going to cut equal lengths, 8 equal lengths. I measured and scaled this with using the metric. So 20 millimeter, this is 20 millimeter, and that's 20 millimeter, and that's what I'm going to cut these at. And it scaled really well with this, even though you can tell that this is a little bit bigger than it should be in this photo. But like I said, it fits our dash a little bit better, and it still gets the same effect. It still causes the same effect. So what we're going to do is going to cut 8 pieces of this, 20 millimeters long, and then I'll figure out how wide I need to cut this piece here. Then I'm going to chuck each piece into the lathe. I'm going to turn it down, because on these you can notice, especially right here and right here, that the washers aren't perfectly centered. I know they probably plan to have them centered, but odds are there's just a stud holding all this together, and the washers just kind of moved around. So I'm actually going to machine a shoulder onto this to accept this hole in the washer, so it'll fit nice and centered. Then I'm going to drill through each piece, tap each piece, and we're going to assemble the whole thing with number 10 screws and drill straight through here. And all the angles, we're just going to cut an angle and it'll lay forward or lay back. I'm going to figure out how to lay all that out, but that's what we're going to do. I'm going to get to cutting this aluminum, and then we're going to chuck them up in the lathe. Alright, now I've got most of these pieces assembled and ready to go, and they'll go up here on the dash just like this. Now, 2 of these guys are going to sit at an angle, one here and one up here. So I've put 2 of these together already. These will be the straight up and down guys. So 2 of these lowers I'm going to set up in the mill and machine them off at an angle so they will sit like this at an angle. So I'm going to do that, but before we get too deep into that, I've got some stuff over here in the little mini smelter I have in the shop. The shop's miniature electric smelter. I think it goes up to like 3,000 degrees. It's pretty cool when you want to do small stuff. When you want to do big stuff, it's not so great. But what I do have is I have some pewter in there, and that's what we're going to use to make the top greeblies. We're actually going to make those out of metal instead of using resin ones, which I have plenty of resin ones laying around, and I could just use those right away. I still want to make all these controls out of metal. So let's go over here and check that out. Here is the mini smelter. It's currently set at 560 degrees. Pewter will melt somewhere in the high 400s to mid 500s depending on its alloy, what other metals are mixed in with it, whether it's tin or they don't make lead. They don't make pewter with lead in it anymore. I think what I'm using has got a lot of tin in it, so it just got fired up, so it's not quite melting yet. Once it gets to fully melted, I have a silicone mold. Now this is the mold I normally use for pouring resin pieces. This is this little piece here, this little greebly, which I thought I had one laying around. Oh well, there's one laying around here on the table somewhere. I think we've talked about it already before, so I don't need to show you. But this is a dragon skin mold. It's a product made by Smooth On. This actually has the ability to handle about 500 degrees Fahrenheit as far as what's poured into it, what temperature it's able to stand. So I'm going to be pushing that a little bit today. I'm going to be we'll probably be pouring it somewhere around 555, 550 degrees. Now ideally with pewter, you want to preheat your molds. I've tried to fire up my little easy bake oven to get this up to about 450 degrees, which will help in the pouring process. But every time it goes through a heating cycle, it tends to blow a breaker, and I'm not sure what the problem is, and I don't really have time to sort it out. I've actually changed it on different circuits and it still does the same thing, so it might actually have a problem inside, but that's for another day. So once the pewter is heated up, ready to pour, I'll start pouring these. I need 4 of these. So while we're waiting for this material to melt, let's head over to the mill and cut some of these pieces at an angle so we can start mounting pieces to the dash. Alright, so you can see right now we're set up for milling, and actually the tool post holder is actually the milling vise on this particular little machine. This is one of those combo machines, and lots of little pieces do multiple things. So I need to get the tool post off, reorient this, which also works as your compound. I'm going to switch this around, set it up to be used as a vise, and then we'll swing the milling head around, grab some end mill, and cut those pieces. Alright, I've decided not to be I'm not picking any special angle. I'm just going to angle it. The reason why is these are supposed to simulate moving levers, so they could be a little bit further or a little bit less. They don't have to be exactly on any particular angle, and I think that's just what I'm going to go with. Go. That'll work perfect. There we go. That's exactly what I wanted, and looks good. So all I really need to do real quick is to chase out the threads, make sure it'll thread real good. These guys will be ready to mount on. There you go. Alright, these guys are ready to put together. We'll put these together, start making these holes in the dash a little bit bigger, and 2 of these holes we're going to have to drill at angles. I'll probably end up having to get longer screws also. Alright, these 2 holes here will be straight up and down. This will be an angled shot, and this one over here is going to be angled. So let's get the straight up and down ones first. All right, now I need to mount the new strut mounts onto the side, and what I've done here is I got a little bit of masking tape with the holes already marked in it. So I'm going to line this up where it looks best, just like so. I want to hold it down. Now I got my holes I can drill out right here. Once this is drilled and mounted, I'm going to use these to create a similar style joint to accept the strut. Now, with this mounted, I am going to create two new mounts for the strut to attach to here. And I've got to make these mounts first and then attach them where I want them attached, so I can then measure the distance from here to there and know how long to make the strut. All right, I keep messing. I've been making these little mount tabs, or little mounts. The reason why I was making these is because this has a weird angle coming in, and I wanted to be able to have this free twisting so it would adjust and line up easily here without a lot of work. But I'm actually not liking this. I'm not liking these. They're all drilled and ready to go. All I had to do was line up, drill and tap this, and then measure between here and there to give me the distance for the part I want to, for the strut that I'm making. I don't like that. It's not turning out, and I'm looking back at the originals, the screen used bikes, and the funny thing about the bikes is none of them are exactly the same. They're all a little bit different. So there's combination of features that are on several of the different bikes, but we're not building this as a replica of one single bike. It's kind of like a collection of a lot of different, like we like the dash better on this one. The strut design is better on this one. Some have a pie piece cut out here and this piece sits on it, and others are just flush and the pie piece sits on it. Some of the pie pieces are smooth, some have angles. Our original one did have angles cut in it, and it was more accurate to the one we were modeling. But others were just flat. Some have pips back here, some don't have pips. But this strut design that we used was modeled after probably the one that we had the best pictures of the strut. And I'm reproducing those struts. This is one of the original wooden struts, or third or fourth strut we replaced because they always break. And one of the problems we've always had over the years is these controls, when people sit down, they can't do this and pop and break all this apart. By making these out of aluminum and fastening everything, it's going to make these solid and hopefully get rid of that whole breaking problem we've had. We usually tell people don't move the controls. They're very delicate when they go and sit on the bike, but kids don't listen. A lot of adults don't listen. So we're always having to beef the bike up for basically people that don't listen. but it's pretty stout. Everything on it's very stout and has held up very well, except for these. And we're always constantly repairing these, fixing these, making new pieces, always out of wood, always last minute, because we realize, oh, everything got broke last year or last event, and we end up making everything at the last minute, and we're not going to do that anymore. Hopefully this is going to be a permanent fix, and we'll fix all these issues. So I'm going to measure, and I'm going to attach it. The reason why I didn't want to do it this way is because this is going to come in at a weird angle, and I'm going to have to match that angle so they'll slide together. I'm going to have to drill this out to match the angle the strut's coming from. And the other side, since this is all handmade, the angle's a little bit different. So if I dial an angle in on this one, it won't be the same angle I dial in on the other side. So I wanted to make my life a little bit easier and make these pieces so I didn't have to dial anything in. Just bolt these on, and then I could set it in here and then bring it up and line it up in here and then bolt the whole thing together. And this has that ability to twist and accommodate that angle. But I don't like the way it looks, and I'm kind of not liking the way it's going to turn out after thinking it through. So what I'm going to do is I'm going to measure from here to there. So this, I'm going to go from point to point 6.5 inches to the base here, and I'm going to add another 1/2 inch. I'll make the overall control struts 7 inches long. I'm going to go ahead and cut those pieces off. This one's just over 7 inches, so that should be about right. I'm going to make them about 7 inches long. Then I'm going to lay out the cuts and everything I need to do on the lathe. But the first thing I'm going to do is I'm going to cut off 2 7-inch, 3/4 inch aluminum rods on the lathe, and then switch everything over to a collet instead of using the chuck. The collet works much better. It's a lot more secure. And I'll switch over to the collet, and then I'll machine the struts that way, and using the picture of an original, kind of map it out and see how we want to make it. So let's get started with that. Alright, first thing I'm going to do is I'm actually going to center drill this piece right here so I can use the tailstock to support, since these pieces are going to be fairly long. So supporting it with the tailstock is pretty much a necessity. This is the part we're making. This is the end that's actually chucked up in the collet, and this will be the end that's down by the tailstock, and this is where this is also the end where it will sit into this strut mount here. So this is already at the proper OD where it's in the collet. It's going to stay 3/4. Looks like it kind of cones down to a very thin and then cones back up, and then so I'm going to take a quick measurement, try to figure out the spacing on all these pieces, and then adapt that to my piece of aluminum so I can kind of better lay this out and start cutting. Alright, here we go. This is a sketch. This is a doodle I sketched out to not to scale, but the way I wanted it to look, and this is a scaled picture. So instead of measuring and going out, I'm just going to go ahead and use the calipers to take measurements from this one as I go along. I'm going to start on this end. It's actually chucked up backwards. I'm going to start on this end and work my way down. So this is the first measurement I need to do. It's 6 millimeters round, and real quick I can tell you it is roughly 37 millimeters long. So that's how I'm going to do this. I'm just going to take these measurements as I go and cut accordingly. There we go. There's the very first one. I'm going to go ahead and machine the second one, but I'm not going to bore you with doing that. But here's the first one. I'll make the second one exactly like this one, and then we'll fit them on the bike. And then we're going to figure out how to paint these. I think this area here and here are going to be left metal, and the rest of it's going to be black and then, of course, weathered. But there it is. There's the first one done. It didn't take that long. Now that I've got it all mocked out, I'm going to use this as reference to make the other one exactly like this one. Now we got the holes drilled. I got the angle pretty good, it looks like. They fit in right there, and everything slides together. And there you go. So we're going to end up drilling and pinning this, or drilling and bolting this. This we'll put together with epoxy. But before I glue this piece in, I want to put some color on these pieces. So I think I'm going to use, instead of using paint, I'm going to use ink. And the reason why I want to use ink is it gives it kind of a blued look, kind of like the way older style firearms used to look. That heat-treated blued look. So that's what I'm going to do to these, and hopefully it turns out pretty good. It should turn out pretty good. So let's go do that. This has had time to dry now, so I'm going to take a little red scuff pad and do a little weathering to it. Yeah, so I'm going to glue this together using JB Weld Fast. Anyway, I got JB Weld here. We're going to use that to glue these guys together. Alright, get it mixed up. Alright, let's take a little bit. Let's take this off. What we're going to do, there's just a little bit of this JB Weld. And dab it in the hole. A little bit more. Alright, we'll place this in, bring this back down, so it'll hold it in a proper orientation. Make sure I'm going to tighten these screws up a little bit back here. There we go. Alright, let's go do the other side. Just like the other side, pull this up, get that out of there. In there, bring that down. There we go. Let that sit. Let those two things sit overnight, and they should be good to go. Next thing we'll do is get ready to paint these pieces, and actually get ready to paint all these other pieces also. Alright, now we got everything glued together. I'm going to let this sit overnight, and then tomorrow I'm going to take it apart and start prepping everything for paint. I got tons to paint. I got front end pieces, I got dash pieces, we got some pieces that I don't even have sitting out here yet. We're also going to go ahead and assemble everything and weather it and get the bike all completely done. But that's going to be for next episode. But before we leave, I want to talk about the bike's mission. For about 10 or 12 years, the bike has been working with small, homegrown type of local charities. We always work with autism charities. For the last several years, we've been working with a group, or actually been working with a school called the Cincinnati Center for Autism. It's actually right down the street from here. It's right here on this street that I live on. So every time the bike goes out, it is raising money and helping to support them. So I'm actually going to leave a link in the description to their website, and you can see what they're all about, and possibly even send them a little donation, a little bit of help or whatever. By the time you see this bike will actually be on the con floor doing its job, having photo ops and accepting donations and all that fun stuff. So until next week, I'll see you then.